Welcome to MRL. In this learning session, we'll learn about a sphere. A sphere is a solid figure. It has only one surface. You have seen a cricket ball. It is a sphere. It has only one surface. Now the fixed distance, there is a fixed point in a sphere called as the center of the sphere. From the center of the sphere to any point on the surface of the sphere is a fixed distance, and that is called as the radius of sphere, denoted by capital R or small r. The circle or a semicircle are plane figures. Remember this. Circle or a semicircle are plane figures. If you rotate a circle about its diameter, any diameter, and also a semicircle about its diameter, we get a solid figure known as sphere. So the plane figures which generate a sphere are circle and a semicircle. Now the surface area of a sphere, since it has only one surface, so surface area of a sphere is 4 pi r square. We'll learn how to derive this. And volume of a sphere is 4 by 3 pi r cube. So please remember that. Now coming to the next very important solid figure, that is hemisphere. Now hemisphere is 1/2 of sphere. That means if you cut the sphere into two parts, each part is a hemisphere. So we have a hemisphere here. But only important difference here is a sphere has only one surface, whereas a hemisphere has two surfaces. It has got a circular surface, which we can call it as the base of the hemisphere, and a curved surface. So there are two surfaces of a hemisphere. So therefore hemisphere has two surfaces, that is curved surface and circular surface. Now if you want to find out the total area of this hemisphere, then find the area of the circular surface, that is area of a circle, that is pi r square, and the curved surface area is 1/2 of the surface area of a sphere, and that is half of 4 pi r square, that is 2 pi r square. So please remember the total surface area of a hemisphere is the area of the circular surface, that is pi r square, plus the area of the curved surface, that is 2 pi r square. So 2 pi r square plus pi r square is 3 pi r square. And also the volume of a hemisphere is 1/2 of the volume of a sphere, and that is 1/2 of 4 by 3 pi r cube. Therefore it will be 2 pi 3 pi r cube. So please remember that. So here I have the two relations for total surface area of hemisphere, which is 2 pi r square plus pi r square, that is curved surface area, plus circular area, that is 2 pi r square plus pi r square, that is 3 pi r square. And the volume of hemisphere is half of the volume of a sphere, that is half into 4 by 3 pi r cube, and that is 2 by 3 pi r cube. So please remember these relations. The circular base of a hemisphere is pi r square. The curved surface area of hemisphere is 2 pi r square, and the total surface area of hemisphere is 3 pi r square, and the volume of hemisphere is 2 by 3 pi r cube. Very important relations to remember. Here let us learn to establish or try to establish the relation for the surface area of a sphere. As we know, a sphere has only one surface. It has a center. All the points on the surface are equidistant from the center, and is the radius of the sphere, and denoted by r. The distance between the center and any point on the surface is the radius of the sphere. Sphere being a non-uniform figure, we cannot directly find the surface area. We have to adopt an indirect method to find its surface area. So let us consider a sphere of radius r. Let us consider a sphere of radius r. So therefore we have a sphere here of radius r. Now the method is wind an inextensible thread on the surface of the sphere. Take a thread and wind it on the surface of the sphere, such that there is no gap between the thread, and also there is no overlapping. So wind the thread such that there is no gap and there is also no overlapping. Now draw 4 circles, circle C1, C2, C3, C4 of the same radius r. Now unwind the thread which we have wound on the sphere on the circles. We find that the length of the thread which is wound on the sphere is enough to wind the thread on 4 circles. Again here the thread has to be wound without any gap and without any overlapping. So the thread which is covering the surface area of a sphere is now covering the surface of the 4 circles, that is C1, C2, C3 and C4. So therefore the surface area of a sphere is the area covered by the thread on the surface of the sphere, and that is equal to the length of the thread wound on its surface, and the length of the thread is equal to the length of the thread which covers the areas of the 4 circles, that is 4 into area of one circle, that is 4 into pi r square, and therefore the surface area of a sphere is 4 pi r square. So please remember that. Now let us learn how to establish the formula for volume of a sphere. Now sphere is a non-uniform solid figure. We cannot again find the volume directly. So what we have to do is go for an indirect method, and the indirect method is very simple. We have to adopt an indirect method of finding the volume of sphere, and the method is now divide the sphere or into number of cones. So now I have taken a sphere here of radius r. I have divided this into innumerable number of cones. The whole surface area of the sphere is divided into different number of cones. I have cone C1, C2, C3, C4 and so on, and we have to find the volume of sphere. The volume of the sphere is equal to the volume of all the cones which form the what you call sphere. Now we know that the volume of one cone, if I take cone C1, the volume of cone C1, that is one cone, is 1 by 3 pi r square h, and pi r1 square, I have taken the first cone, therefore I have taken r1 here. Pi r1 square is the area of the base of the cone. Therefore the volume of the cone C1 is nothing, that is V1 is 1 by 3 B1r, and please understand B1 is the base area of the cone C1 here. Now to find the volume of the sphere, we have to add the volumes of all the cones. Therefore let us see how to find that. Now the sum of the volume of the cones is equal to volume of V1, V2, V3, V4 and so on, innumerable number of cones there, and we know that volume of the cone V1 is 1 by 3 B1r. Similarly the volume of cone C2 is 1 by 3 B2r, V3 is 1 by 3 B3r and so on. We have got innumerable number of cones. Now in this 1 by 3 r is common, so I have taken 1 by 3 r common here, and I have put in the bracket the areas of the bases of all the cones. And we know that if I add the areas of the bases of all the cones, that is nothing but the surface area of the sphere, and therefore the surface area of the sphere is 4 pi r square. So 1 by 3 r into 4 pi r square is equal to 4 by 3 pi r cube, and that is the volume of the sphere.